So our web app has been started and let's wait. So you can see this is the view. An image has been there and one upload and generate image button. And there you go, our image has been generated and it looks cool, and you can save it in your gallery or download it and upload on server as you wish. But your whole image generation API is working via Genkit, and your API has been also protected by a serverless Firebase. Hi everyone, welcome to my channel. My name is Shivam and today we are going to learn about Genkit. So Genkit is an AI framework from Google, and today we are going to implement an app, image generation, and we are going to show this on the front end in the Flutter applications. So I'm going to use Genkit as an AI framework, Firebase as the serverless platform, and Flutter as the front end. Now remember, whatever I'm going to teach you today about Genkit, you can implement this on any front end level, you can host it on any server also. Okay, so let's start. So what is Genkit? So Genkit is an open source AI framework. So as you know that there is already a lot of AI frameworks available, LangChain, Microsoft Agent Framework, Data and Tech. So Genkit is also a new framework that is available with JavaScript, Python and Go. Python is in the development version, but JavaScript and Golang available is still available. So with the Genkit, you can create an AI orchestration framework at the backend level. Currently, this is default. I'm going to use as a Gemini AI provider, but with this, you can implement Gemini, OpenAI, DeepSeek, or any open source model also via Olama endpoints too. So, lot of possibilities available. So you can use any kind of models here. What else Genkit can do? So it also provides Genkit CLI. So Genkit CLI is like a local development. So you can code and you can test it locally, and it provides a developer UI. It's like a web app where you can log and monitor your requests. You can see what function is being called, what input was sent and output was received, how much time it will take to execute each functions, what tokens were sent and what tokens were received. So every data is logged in the developer UI. So Jenkins is also by default supportable to the Firebase, which is a huge plus for the front-end developers, that you can implement a Jenkins and directly call on the front-end side and create your own AI applications. And we are going to do the same today. We are going to make our own image generation applications. So for this, you can set up a Firebase, and you can also implement this on a cloud to have a serverless application, or you can host the Genkit on the custom environment. That means whatever server you already own, you can use ExpressJS or wrap in any endpoint layer you can use on the custom server too. And frameworks is available in JavaScript, Python and Go. In the today's tutorial, I am going to use JavaScript framework. So before going to code, let's see how things work. So this is the architecture I have made to understand that how every data is flowed from the front end to end, and how you get the output in the final. So the first layer is application layer. So you can use Flutter, React, Kotlin or any kind of front end applications to call the Firebase functions or the server API. Now I am using Firebase because it is available via Firebase authentication. So everything is already done. Or you can use your own server, custom server, and implement your own authentication to access via front end. Now this Firebase is easily accessible via cloud function. So I can directly call cloud function on the front end, and the cloud function is actually running the Genkit framework. This Genkit is our actual business logic, that is our AI logic, where we are going to call our Gemini developer API here. And the same Genkit can be hosted on our custom server too. Now with this Genkit, what else you can do? As you can see that I'm already using Gemini provider, but you can use other AI providers like DeepSeek and OpenAI. I can also implement my own custom server here, or I can use any other third-party services. Like if I want to connect with database services, I want to connect with other third-party REST API, I can also implement and call and utilize in our Genkit application. Let's code now. So first we have to create our Firebase project. Now to proceed with this step, there are multiple ways, but I am using Firebase because I want to implement the Firebase on the front-end application. So I can call the Genkit. So here I have created a new project called class project here. And if you go there, first we are going to add our front-end application. So I am using Flutter. So I have already added a package name here with the app ID, and we're going to add this information on the front end. Now you can enable the Gemini API keys via two ways. First, you can go to the AI logic here and enable the Google Developer APIs. So here it is already available in the settings, so I don't need to. The other way is go to Google Cloud Console. So if you go to Google Cloud Consoles, click Enable APIs here and type Gemini and select Gemini Google APIs key and enable the APIs. After enabling, go to the credentials, API service credentials. Now here create a new API key here and name it Gemini API and copy this API key for the later use. So our API key is ready and our Firebase setup is ready for the front-end application. Now let's start with the coding of the Genkit. So this is my project folder. So here I have already created a Flutter application. This is a blank Flutter application here. And outside this Flutter application, I am going to create our Genkit service. So created another folder here and added Genkit service here. So in this blank folder, open this in the terminal and make sure you install the Firebase CLI tool because that is necessary to set up the Genkit on the local developer site. So I am going to type Firebase login. Click enter. This way Firebase login will have access to your Firebase project from the Google Cloud Console. So as you can see, my Firebase login is already authenticated. I am going to proceed with the next step. So now I'm going to initialize a Firebase Genkit project here. So type here in the new folder Firebase init Genkit. So this is going to install Firebase Genkit CLI for the developer purpose. So it's saying, are you ready to proceed? Yes. It's asking to select the project. So we just created a new project in the Firebase. I'm going to use the existing one. I am going to use class project that we are going to use in this project. So this project will host the Firebase Flutter usage also and Genkit usage also. So it's asking to initialize the Firebase function. Yes, because during the Firebase function, we are going to call the Genkit code. We cannot call Genkit code directly from the front end. We need some kind of access layer. Do you want ESLint? No, not for this. I'm going to use TypeScript, but you can use JavaScript also. Do you want to install dependencies? Yes. So it's asking to install Genkit CLI globally. I will choose the globally purpose. So we can use this Genkit CLI for other projects also. Now it's asking which model provider we want to use. Google Cloud Vertex here. We are not going to use Vertex AI. For advanced features, we can select this. But for now, we are going to use Google AI only. So you can implement Vertex AI for advanced features like RAG service. So if you want me to create a new video on the RAG service with Genkit AI, comment below and I will make it. For now, we are going to use normally Gemini developer APIs. It's asking to update your TS config. Yes. Update your packages. Yes. To generate sample flow, no, we are going to make a application from the scratch and that's it. So let's open the folder here and now you can see our Firebase has been initialized and there is a function folder. So all the code of the Genkit will be in the function folder because we are going to deploy this on the Firebase cloud functions. So if we open the function, there is a node module source folder where we are going to write our code and then there is a package.json. We are going to install the dependencies. So here they have already added by default Genkit, Firebase functions, Firebase admins and Express. So we are going to add new dependencies here. I'm going to add npm install Genkit Google AI Gen AI because we are going to use Gemini AI provider. And second is .env. .env is only useful for the local deployment, but we are going to deploy on the server. They will be different use case. So I open the index.js. So there is a predefined code. We are going to remove this. And I'm going to paste the actual code here. Instead of code typing in the whole video, I'm actually giving you the explanation part so you can understand everything line by line here. So first part is dev only. This is for development only, that we are going to use an environment key of the Gemini API, and the production there is a different use case. So for that, go in the source folder outside the functions and create a .env file here. And here type Gemini API key and we are going to paste our API key here and we are going to copy this API key from our Google Cloud Console and paste it here. Okay. So at this line you can see the environment file is being loaded from the .env and it will set a Gemini API key as an environment variable. So this will be stored in the API key that we'll use later. Second one is enable Firebase telemetry. This is for logging purpose. So every process is being input is being sent, token is being generated, output is being logged here by the Genkit Firebase. So you can enable it by default. So first we are going to implement our Gemini API provider because we are going to use Gemini for our image generation. So for this I am going to use a Genkit function here, and in this I'm going to provide Google AI as a provider because I'm going to use Google AI. Now you can pass multiple AI providers to here, and then add a parameter model Google AI model Gemini 2.5 flash image, that is Nano Banana. This is the code name of the Nano Banana. So if you want to implement other Gemini models like for text generation, for audio generation, you can go to this page, Gemini AI Logic. Although this is only for Gemini AI Logic, but here you can refer the code names. So suppose you want to use Gemini 2.5 flash, so you can use this name. For Pro you can use this label. For the image generation I am using 2.5 flash image for the imaging models, and so on. This way you can generate image, text and videos. So next is we have to define the input and output schema. That means whatever the input is going to receive by the Genkit code, we have to mention a structure for this. So for this I am creating a variable called input schema z.object. This is our object like a JSON object, and key name user image. So if we are going to send a payload from the front end, the key name should be user image, and I am going to pass this as a string. What will be this string? Image in base64 format to be modified. That means I am going to send an image in the base64 from the front end in the payload with the key name user image. So if the image size is low, like less than 1 MB, you can implement a base64 method. If image is of higher size, you can implement a cloud storage. That means from the front end, you can send image directly to the cloud storage, and here you can pass the cloud storage links and download here and then utilize it. Now we have initialized output schema. So output schema contains one key, output key, and the string as a format. So in the return, while the image is being generated, I am going to convert this in the base64 and then pass it to the front end side. So front end can decode it, that image, and then show it on the front end side. So our input and output schema is ready. Okay. So next part is define flow. So let's talk about what is flows. So let's see what are flows in the Genkit. So flow is a special Genkit function that wraps your AI logic. That means every AI call you are going to make, every time you generate a token, embeddings, rags, MCP, everything is going via this flow functions. So the flow function, what it does, it logs everything. If you are implementing something outside flow, you will not be seeing the logs on the developer UI that is provided by Genkit, but you can still log on the Google Cloud console, but it will not be available via Genkit. Types of input and output. We just saw we implemented an input schema and output schema. That means whatever the input and output will be sent, that will be in the fixed format. If there is some different format is being sent, it will throw an error. So observability, testing on UI and debugging. So both comes under the developer UI that is going to be provided by the Genkit. So in the Genkit, we can execute our function manually and we can see all the logs, all the process that is happening, and if there is an error during the flow execution. Deployment. So we don't have to add any extra step while deploying Genkit services. So everything is handled by Genkit. We just need to push our code on the Firebase function and everything is being taken care of. So now I'm going to use this AI object and implement our define flow. So for this, I am using AI define flow function, and this contains few parameters and an async function. So this AC function is a place that we are going to add logic, whether it's an API provider or a database connection, everything will goes in this async function. Then the parameter is a unique label you have to mention. So every time you are creating a new flow, you have to create a new unique label. This is how it's going to be defined by the Genkit. Then in the input schema, we can directly pass this object directly, but I have created a variable here. And then we have passed the output schema. So everything has been taken care of by this, how to handle the input and output. So in the async function, we get two parameters. One is input and other is send chunk. So input is the actual input schema that we are going to use actually in the front-end application, and other one is send chunk. So if we want to stream the data and send the output in the stream formats, we are going to use the send chunk. In this scenario, we are not using this send chunk function. So here is the first statement. So here I have declared first variable is system prompt. So act as a helpful assistant that create creative and engaging images from images provided by the users. So every time we are going to call an AI provider, we have to assign some kind of role. So for this I have used system prompt. Now this is an image prompt. This is the actual prompt that is going to convert the user image that is sent by the user and actually convert into a 3D awesome looking images. So our prompt is convert the photo into an epic 3D anime style action scene. The person is jumping outside the building. The user rich blue-green color palette throughout the entire image. render in ultra high definition DSLR style photorealistic artwork, change clothes. So whatever user will send image, it will imagine a new cloth and it will create a new character according to that. Use user image as a reference for face, body shape and outfit. So it maintains some kind of consistency with respect to the user image. To send a multi-prompt, I am going to use Spark class. So in this Spark class, I am passing an array. This array contains one object which is media. In the URL key, you have to pass this prefix data image png base 64 and then the actual base 64 that is being sent by the user. So input is the same that is being sent by the async function, as you can see here. And out user image. User image is the schema that we have mentioned here. So from this, the base 64 as a string format will be set in the first object. In the second object, this is a text prompt. So we are passing our text prompt as it is. Now we are sending our prompts and data to the Gemini LLM. So for this, there is another flow provided by the Genkit, ai.generate. So this will handle all the process, input and output, everything. Just we have to pass the parameters here. So for this prompt, I have passed the prompt variable, that is the multipart here. You can see the array and the system prompt to assign a role to the LLM. And in the return, I have added await, so it will generate a response in the JSON object. So here I can get two kinds of output. First is output media URL. This is a nested JSON object. So in the media, in the URL, I can get a base 64, that is generated image sent by the Gemini LLM. And the other output I might get, suppose in case this is null, I might get output.text. So this is the error. That means if you are going to asking a generate an image that violates copyright, so LM might not return an image and it will send a response like due to copyright violation we cannot generate an image. So it will ask for another prompt. So in those scenarios I have passed output as a text. So this final response, it will be sent to the Firebase function, and in return Firebase function will forward this to the front end where the APIs were called. Now till now our Genkit work is done. That means we are going to send an image from the user side and it will generate an output and it will return back. But till now this Genkit service is not available to the Firebase function, hence it is not available to the front end too. Now to test this Genkit on our local host, I am going to run this command genkit start --npx tsx source index.ts. Now before executing, make sure that you are in the function folder, not in the actual Genkit service folder, but in the function folder here. Okay, click on it and it will start a local host, and it will start a local host and it will provide a UI for Genkit developer UI. So it's throwing an error. Let's see. It says unable to detect project ID in the current environment. Okay, so we need to pass a project ID also. So for that, what I'm going to do, exit it, going to the environment file. So in the environment file, I'm going to add a new variable Google Cloud project and add your own Google Cloud Console project ID here. So if we just add the environment here, using this code, those both environment variables will be loaded and they should work. Okay, so let's try again. Start a local host. Okay, this time no error. So we are going to open this local host. So now you can see Genkit has provided a web application on the local host to test the Genkit service. So you can see there are a lot of options are available, but we are going to use only one for now. You can see there is a model option. So we are not restricted to the one model. For testing purposes, we can use multiple Gemini models here for the testing purpose. Now we are going to use flows. This is our flow that we just created to generate an image. Click on flows. So as you can see in the input JSON, that JSON is already provided with the key pair user image with the empty. That means we have to pass the value here. So because the value is in the image as a base 64, we are going to use any online decoder encoder of the base 64. So here I am going to pass one image here. That is my image. And I'm going to convert this into base 64 directly. We are going to do this exactly same from the front end too. Copy this base 64 and pass this as a value. Okay, now run. And now you can see output has been generated with the key output, and just click on it. An image has been generated as a base 64. If you click on the raw, this is our raw response replied from the Gemini. So after the output has generated, if we click on here view trace, then you can see all the logs have been mentioned here. So if we click on the image generation flow, whatever the input has been provided and whatever the output has been provided, it's being mentioned here. How much duration it takes 12 seconds to execute, what is the start time, end time, what was the flow name, what was the state, is success or failure. Now from here we can check other functions, that is inbuilt function that is provided by the Genkit. So we use AI generate function. If we click on it, I pass my own image. You can see this is the system prop that I pass. This is my actual image that I put as an input, and this is the actual output. So now everything is working. Our image has been generated. That means our code is working properly on the localhost. Now we are going to deploy this on the Firebase function. So for this, go back to the code. Now use this image generation flow object and wrap this object into the on-call Genkit function. This Genkit function is provided by Firebase functions. So if we wrap this in our on-call Genkit, this endpoint, that means this Genkit flow, will be available on the Firebase, and now it's callable on the front-end side. And because we need Gemini developer AI key, for that first we are going to go above. Now our image generation also need a Gemini developer key. So we cannot use .env there on the production. So for this we are also passing a value in the secret. Okay. So how to get this API? We will not use .env now. We are going to comment this code. Okay. This is for development only. And we are going to use production use case. So in the production, we have to use define secret function and pass the secret key that we have mentioned in the secret manager. So we can set this API key directly from the terminal to the Google Secret Manager on the Google Cloud. So I'm going to exit our localhost, clear it, and run this command. Firebase functions secret set Gemini API key. Click enter. Now it will ask for a value. Let's go to the environment file, copy our API key here. Okay. Now it's asking to enter the value of Gemini API key, paste it, click enter. The value received. Now this will generate a Gemini API key secret variable on the Google Secret Manager. So let's go to the Secret Manager here. Go to the menu, security, and go to Secret Manager. Now you can see we just created a Gemini API key from the terminal, and it has been created here, and value has been set automatically. Now we're going to back to the code. Now to deploy this Firebase function, make sure you are not in the function folder. For this we have to take one step back and go to the Genkit service, that is outside the function folder. This is our Firebase function code. So type here Firebase deploy -- only Firebase functions, enter. Now this is going to deploy the Firebase function on the Firebase console. So while it's being deployed on the Firebase function, I will let you know that I have not added any kind of Firebase authentication or token authentication here. So that means the app can directly call the Firebase function without any authentications. You can add authentications and we can enable that parameters too. So now our Firebase function is deployed. Let's go to the Firebase console. And now you can see that we have a function named image generation. So this image generation is matched with this object here, image generation. Okay, this is not the flow name, this is actually the function name. So this is our flow name and this is our function name. So now our Genkit service is hosted on the Firebase. Now let's implement this on the Flutter application on the front end side. So this is a basic Flutter application where image will is already provided and it will generate a new image here. So first thing we have to do add a Firebase. So to add a Firebase, first we have to go perfect.yaml. So you have to add these packages: Firebase core to initialize the Firebase in your application, .env to load my Firebase config dynamically from the environment file. So here I have created an environment file, and from here I am going to initialize the Firebase in the applications. You can decide your own way, whatever method you prefer to initialize the Firebase. Next we added a widget initialize, loaded an environment variable, and initialize the Firebase from the Firebase default option that I have created already here. Okay, so Firebase has been initialized. Let's see the actual implementation. So for this, I have created a basic view here. This basic view has one image from the asset image that is going to be converted. So if we go to the asset, and we can see that I have added one image here. Okay, this image will be converted into the generative AI image. For this, I have added a boolean parameter is loading. That means when the process will start, it will show a loading indicator here, or it will show a button here. Okay, let me show you. So I am going to use the web app because Flutter can run on the web app also, and Firebase will work on same on the web application too. So our web app has been started, and let's wait. So you can see this is the view, an image has been there, and one upload and generate image button. So this is our related button, that is upload and generate image here, and this will call a function upload and generate. And when this function is going to generate a response from the Genkit in the bytes format, I am going to load that byte in the final image, and this will show in the image.memory. So let's go to the upload image generate. So here is the first thing we have to do is to load the image locally from the asset folder. You can ask the user choice from the gallery, or you can download from the URL link also, that will work same. And I am converting that into the base64 string before sending to the server. So for this I have initialized Firebase function instance HTTPS callable image generation. Now this image generation should match this image generation function name. Okay, and then call function with the parameters that I have to send. So this parameter need to be matched that I have created in the Genkit. Okay, and I have sent a base64 as a string. We will get a response, and the response will contain an object, that is output, that we created an output schema previously, and this will contain a base60 format. Now this Firebase function will call the Genkit code, and Genkit code will call the Gemini API key, and it will return the image as a base64. And this data will be in the base60 format. And finally reformatting it and decoding it, we are getting in the format of uint list, and I'm going to set this here in the final image. So let's try this. And there you go, our image has been generated and it looks cool, and you can save it in your gallery or download it and upload on server as you wish. But your whole image generation API is working via Genkit, and your API has been also protected by a serverless Firebase. So now we have created a service, but what else we can do in the Genkit? So you can see that agentic flows can be made with the Genkit. That means you can attach multiple tools like database connection, REST APIs, your own custom business logic. You can attach with the Genkit and it will execute as per your user prompt. Firebase integration. So as you can see, with 1 or 2 lines execution, we can easily deploy our Genkit service on the Firebase, and it's easily accessible via Firebase function to the any application provider. RAG vector search context aware retrieval pipeline. That means if you want to read content from the PDF, images, videos, and you can create embeddings, store it and retrieve it when you need it, you can implement a whole RAG pipeline on the Genkit service. Observability dashboard, tracing metrics, tokens and outputs. Plugin ecosystem, extend the API. That means you are not just restricted to Gemini API. You can implement any kind of AI provider, any kind of REST API, SQLite connection to any kind of third-party database. Anything is possible. So I hope you like this video on the Genkit. And if you have any question regarding Firebase or Genkit, you can comment below. Till then, keep learning. Bye.